You are welcome back to this channel. So in today's class, we are going to teach matrices. So at the end of this class, you should be able to define a matrix, types of matrices, and perform basic operations on matrices. That is addition, subtraction, and multiplication of matrices. What is a matrix? A matrix is the arrangement of numbers, be it complex numbers, real numbers, or trigonometric functions. So you arrange all those numbers horizontally and vertically to form a rectangular pattern. So generally, we define a matrix. A matrix is defined as the arrangement of numbers in a rectangular array or pattern. So what I'm saying in essence is that you are all familiar with rectangle. So rectangle has length and breadth. So this length is the horizontal line. This is the horizontal line, and here is the vertical line. So we want to arrange numbers that will be in form of this rectangular pattern. So let's look at these numbers. If I have 1, 2, 3, you can see that all these numbers lie on a horizontal line. So if I want to arrange vertical now, I have, so vertical will start from 1. Let's say I have 4, 5, 6. So this is horizontal, this is vertical. So it doesn't look like a rectangle that I want. So I still have, let's say I have 0, minus 1, minus 5, 8, 7, 9. So you can see that it has looked like a rectangle now. Look at it. So I have horizontal. This is the first horizontal line, the second horizontal line, third horizontal line, and this is the fourth horizontal line. So we arrange it in the horizontal and vertical line. So for it to become a matrix, so you have to enclose it in a bracket. These arrangements of numbers, we are going to enclose it in a bracket. So if you see any kind of arrangement of number like this, you should know that they are talking of matrix. And I want you to note that there is no commas there. We are not separating those numbers with commas. So you have to take note of that. It's either you use this bracket or you use another bracket like this. So if you have 2, 3, 4, 5, minus 1, 0, minus 1, 2. So this is another matrix. You can see it's the same thing. It's either you use this kind of matrix and bracket or you use this kind of bracket. We are still talking about matrix. Now, another thing that you need to know is that this is horizontal 1. So this horizontal is known as row. This is row 1. Here is row 2. So the second horizontal line is what? Row 3. Now, those that lie in vertical line. So here, that is 2, 4, 0. You can see, so this is vertical line. So this is column 1. So those numbers that lie on the vertical line, they are known as column of a matrix. So this is column 1. Here is what? Column 2. Here is column 2. And here is column 3. So in matrix, you will have rows and you will have columns. So rows, all the numbers that lie on horizontal line, and column, vertical line. So in this matrix now, you can see that it has 3 rows and 3 columns. So it is the row that you mention first in matrix. Then you mention column next. Now let's go to order of matrices. Now order of matrices will be the number of rows and number of columns that a particular matrix has. So here now you can see that it has 3 rows. So it has 3 rows. And how many columns? It has 3 columns as well. So if you want to tell the order of this matrix now, you now see that this is order 3 by 3. So you write it 3 multiplied by 3, but if you want to read it, you say that 3 by 3. So this is order 3 by 3. Now let's check this matrix here. What is the order of this matrix? So let's see how many rows and how many columns does it have. So it has, this is row 1, this is row 2, here is row 3, and last but not least, row 4. So let's check the columns. Column 1, column 2, and column 3. So if you want to write the order of this particular matrix, I told you that you are saying row first. So how many rows? You can say that it has 4 rows and 3 columns. So its order will be order 4 by 3. That is, it has 4 rows and 3 columns. So that is how to know the order of a particular column. Then, before I forget, matrices is the plural of matrix. Matrix is singular, while matrices is plural. So, after getting the order of any matrices, now it is important for you to know that we use capital letter to denote a matrix. So if I want to talk about this matrix now, maybe I say this is matrix A. So I'm not going to write this in small letters. So you are writing matrix in capital letter. And each member of a matrix is known as elements. So here we can see that it has elements 1, 2, 3, and 4. So all these members 1, 2, 3, 4, 5, 6, they are elements of this matrix. So note. Another thing that you have to know is that you can use letters to denote the elements of any given matrix. For example, let's say this is matrix A. So I can say that this is the A11, A12, A13, then A21, A22, A23. I can stop here. So here, this one has how many rows? It has 2 rows. This is row 1, this is row 2. And here is a column 1. Here is what? Column 2. Vertical. And here is what? Column 3. So the order of this matrix is what? This is order what? You are telling row first. Order 2, then column 2 by 3. This is order 2 by 3. Now, what is this 1, 1 here? This A11. It means that this element lies in the first row. No, I told you that you are saying row first. First row and first column. That is, it lies in the first row. This is the first row, and here is the first column. So if I take A12, A12 means first, it lies in the first row and second column. So let's check. So A11, you can see it lies in the first row but lies in the second column. So similarly, this A13 lies in the first row and third column. So that's the meaning. So A21 lies in the second row and first column. A22 lies in the second row and second column. A23 lies in the second row and third column. So you have to note all these things. Now, let's go to types of matrices now. Types of matrices. We have row matrix, column matrix, zero or null matrix, square matrix, diagonal matrix, unit or identity matrix. A matrix is said to be a row matrix if it has just one row. Yes, it has just one row. That is, if we have, for example, this is row, right? So all the line numbers have to lie on this. Say I have 1, 2, 3. So then bracket it. So how many rows now? It has one row, irrespective of number of column. It has one row, then column 1, column 2, column 3. So what is the order of this matrix? The order of this matrix is 1 by 3 matrix. So anytime you see a matrix that has just one row, just a row, you know that this is a row matrix. So a matrix is said to be a row matrix if it has just one row. Column matrix. A matrix is said to be a column matrix if it has one column. Here is column, vertical. So you arrange a number in a vertical order. So let's say I have 5 minus 6, 7, 9. So irrespective of number of rows that it has, inasmuch that is in just one vertical line, column. So that means it's a column matrix. So you can see here it has row 1, row 2, row 3, and row 4. So it has column, one column. So what is the order of this matrix? The order of this matrix, this is order 4 by 1. So here is the column. So since it has just one column, that means it is a column matrix. Zero or null matrix. This is a type of matrix that all its elements are 0 and it is denoted with 0. So it's denoted with 0, so all its elements are 0. Any one or 0, 0, 0, any other. So this is a 0 or null matrix. This is order 2 by 2. This is 1, 2, 3. So 3, 1, 2, 3, 4. 3 by 4. So it doesn't matter. Order doesn't matter. In as much all its elements are zeros. A square matrix. A matrix is said to be a square matrix if the number of its row is the same thing as number of its column. Now, what I'm trying to say is that if our row, if we use n to be our row, then column is also n. So let's say we have a matrix A to be A11, A12, A13. So we have A21, A22, A23, A31, A32, A33. So it has row 1, row 2, row 3, column 1, column 2, column 3. So you can see that the number of rows is the same thing as number of columns. So this is example of a square matrix. So this is 3 by 3 matrix, and it is a square matrix. Another one, if we have square B, be equal to B11, B12, B21, B22. You can see that this one has two rows and 2 columns. So this is order 2 by 2. So it is a square matrix. Similarly, if we have your matrix C to be equal to, let's say C11. So this is row 1, this is column 1. So this is 1 by 1, and it is a square matrix. So a diagonal matrix. A square matrix is said to be a diagonal if all the its elements are zeros, except those that are in the leading diagonal. So for you to define a diagonal matrix, it has to be a square matrix. Now, what is a leading diagonal? Let's say I have a square matrix A to be equal to A11, A12, A21, A22. Now, you know this one has 2 diagonals, but this one that has the beginning and the end, this is the leading diagonal. So here is the leading diagonal. To be a diagonal matrix, every other element here will be 0 except those that are here, that are in the leading diagonal. So D is equal to, let's say the first element here is -2, 0. Here will be 0, and this also will be 0. So here, let's say 3. So you can see that the leading diagonal are not 0. So another one, let's say we have matrix 1, 0, 0, 0, 0, 0, 0, 0, 5. So here is the leading diagonal. Here is the leading diagonal. So this is also a diagonal matrix. It doesn't matter this 0 here, in as much every other numbers are not 0. So it's a diagonal matrix. Now, a unit or an identity matrix. A square matrix is said to be a unit or an identity matrix if all its elements are zeros, except those ones that are in the leading diagonal that they are 1. Now, I've explained the leading diagonal for you, that this is the leading diagonal. If it is 3 by 3, we have A11, A12, A13, A21, A22, A23, A31, A32, A33. So the leading diagonal will be here. You can see where the row and column are the same. Row and column are the same, row and column are the same. So that's the leading diagonal. Now, for it to be a unit or an identity matrix, every other element here will be 0, everyone here will be 0, except those ones that are here, that will be 1, 1, 1. So this is, we use I to denote that. For it to be an identity matrix, the first element here will be 1, followed by 0, 0. This side will be 0. So A22 will be 1. Then A23 will be 0. A31 will be 0. A32 will be 0. A33 will be 1. So you can see the leading diagonal here, everything is 1. So this is example of unit matrix. Unit matrix, or you call it an identity matrix. So that is types of matrices that we have. Now, basic operations of matrices. So we are going to treat addition and subtraction of matrices first. Addition and subtraction of matrices. So if you want to perform addition or subtraction of matrices, be it 2 matrices, 3 matrices, or 4 matrices, all those matrices have to be in the same order. That is, they have to have the same order of matrices. Now, what I'm trying to say is that if matrix A is of order 3 by 2, and I want to add it or subtract matrix B from it, so this matrix B must also be of order 3 by 2. So if they are not of the same order, that means they cannot be added together or subtracted from each other. So let's, for example, say that matrix A is equal to 1 minus 2, 0, 3, 4, 1. So you can see that this is what? This is 2 by 3. So this is order 2 by 3. So it means that for me to be able to add it to B, this B must also be 2 by 3 matrix. So let's say I have minus 5, 10, 0, 3, minus 3, 1. So this is order 2 by 3 as well. So if they are not of the same order, that means I cannot add them together. So that is the first thing that you have to check if you want to perform addition or subtraction on any matrices. So check their order. Are they of the same order? So if they are of the same order, that means you can go ahead and add or subtract. But if they are not of the same order, that means you cannot add or subtract. So let's perform the operation on these ones now. So let's say we have A plus B. It will be, let's write our matrix A first, which is 1 minus 2, 0, 3, 4, and 1. Then plus, what is our matrix B? Matrix B here is minus 5, 10, 0, 3, minus 3, and 1. So we can now perform the operation. So the next thing is that the first element of the first matrix, you are going to add it to the first element of the second matrix. That is, you add 1 plus minus 5. So the second element of the first matrix plus the second element of the second matrix gives minus 2 plus 10. You can see it's very simple. So you have the third element of this first matrix plus the second element of the second matrix. That is 0 plus 0. Now, the fourth element of the first matrix plus the fourth element of the second matrix, 3 plus 3. the fifth element of the first matrix plus the fifth element of the second matrix. Similarly, last but not least, the sixth element of the first matrix plus the sixth element of the second matrix. So that is how to perform it. So now we can now say that our A plus B is equal to plus times minus gives us minus. So we have 1 minus 5 and that is minus 4. Minus 2 plus 10 gives 8. What is 0 plus 0? 0. 3 plus 3, 6. Plus multiply by minus gives minus. So this gives 4 minus 3. So what is 4 minus 3? 1. What is 1 plus 1? 2. So we have performed the addition on these two matrices now. So the same way we can perform the subtraction as well. So I can say that this is, let me say I have A minus B. So since they are having the same order, so I can go ahead. Now A, my A, I'm going to write it 1 minus 2, 0, 3, 4, 1. Minus my B, minus 5, 10, 0, 3, minus 3, and 1. So let's perform that operation. So it will be equal to the first one, 1 minus minus 5. Here and here. So followed by this one, minus 2, then minus 10. Then 0 minus 0. Then 3 minus 3. 4 minus minus 3. Then 1 minus 1. So our answer is going to be 1, the minus multiplied by minus, that is plus. So 1 plus 5 is equal to 6. Minus 2 minus 10, that is minus 12. 0 minus 0, 0. 3 minus 3, that is 0. Minus multiplied by minus there is plus, so 4 plus 3 is 7. 1 minus 1 is 0. So can you see? So we have performed the subtraction on those two matrices as well. Now there's another thing that I want us to check. Maybe if we have our B plus A, let's see what we're going to get. So we are going to write our B first, that minus 5, 10, 0, 3, minus 3, 1. Then plus A. A is 1, minus 2, 0, 3, 4, and 1. So let's add them together. So we have minus 5 plus 1, 10 plus minus 2, 0 plus 0, 3 plus 3, minus 3 plus 4, 1 plus 1. So what is the answer? The answer here is minus 4. This is 8, 0, 6. This is 1, and here. So B plus A is now equal to, from this side, minus B and minus 5 plus 1. That is a minus 4. But what is it from a side? Plus multiplied by minus gives us minus. So it becomes 10 minus 2. What's 10 minus 2? 8. So we're going to write 8. 0 plus 0, 0. 3 plus 3, 6. minus 3 plus 4, that is 1, plus 1 plus 1. 1 plus 1 there is 2. So now, what do you observe? Let's check. We can see that what was our A plus B? What did we get? Let's check. We got minus 4, 8, 0, 6, 1, and 2. So you can see that they are the same thing. So you can say that A plus B is the same thing as B plus A. So that means addition of matrices is a commutative. So it obeys commutative rule. So this is commutative property. What do you understand by commutative? Commutative is when you had two numbers or three numbers, and after arranging it, after interchanging it, you still add it, you still get the same thing. For example, if I say 1 plus 5, no, it's still the same thing as 5 plus 1. So that is commutative. Now, that is for addition and subtraction of matrices. So you can perform it for 3 by 3, 4 by 4, 4 by 3. Just make sure those matrices that you want to add, they are of the same order. If they are not of the same order, that means they cannot be added or subtracted from one another. Let's go to multiplication of matrices. We can multiply 2 or more matrices together, but you have to take notes. You have to check the number of columns of the first matrix. Let me say this again. Check the column of the first matrix. Let's say our first matrix is A. So now, let's say it's of order 3 by 4. So what is the column of this matrix? This is a 3 by 3 matrix, 3 by 4 matrix, sorry. So you can see that this is the row of this matrix, this is the column of this matrix. You can see that this matrix A has 4 columns. So you have to check that the column of the first matrix before you perform the multiplication on the 2 or 3 matrices. Now, your matrix B, the second matrix, you check its row. So let's say we have 4 by 3 matrix. Now you can see that this one has 4 rows and 3 columns. This one has 3 rows and 4 columns. So what I told you now is that you check the column of the first matrix, then you check the row of the second matrix. If they are of the same number, if the number of the column of the first matrix is the same thing as the number of row of the second matrix, then you can multiply the matrices together. But perhaps, let's say our first matrix has 3 by 4 and the second matrix has 3 by 3. The first thing you are going to check is the column of the first matrix, which is 4. This is 4 columns. Then you check the row of the second matrix. This is 3 rows. You can see that the number of rows here, are they the same? Anybody? Number of column, let's write number of column. Number of column of the first matrix is 4, and it's not the same thing with the number of rows of the second matrix, which is 3. Number of rows A is 3. So this is matrix B, this is matrix A. So the number of column of matrix A is 4, and the number of row of matrix B is 3. That means they cannot be multiplied together. So what I'm saying in a nutshell is that for you to perform multiplication on matrices, those matrices, you check the column of the first matrix. If the number of column of the first matrix is the same thing as the number of rows of the second matrix, then you can go ahead and multiply them. Unlike addition and subtraction, in addition and subtraction, the two matrices or three matrices that you want to add together, they have to be of the same order. So it is different. If we want to perform multiplication and they are of the same order, if they are of the same order, let's say A is equal to 3 by 2 and B is 3 by 2. You can see the column here is 2, row here is 2. That means they cannot be multiplied together. They cannot be multiplied together. So that is the first thing to check if 2 or 3 matrices can be multiplied together. If the number of column of the first matrix is the same thing as number of rows of the second matrix, then go ahead and multiply them together. Now let me give you an example. For example, if my matrix X is equal to 1, 2, 3, 2, 5, 6, and my matrix Y is equal to 1, 2, minus 3, 4, 5, 6. Now, the first thing that you are going to check is what is the column of this one? 1, 2, 3. It has 3 columns. Now, what is the rows of this one? 1, 2, 3. So this one has 3 rows. Since the number of column here is the same thing as number of row of this one, then I can go ahead and multiply them together. So that is how to check. But if my A is equal to 1, 2, 3, 4, 5, 6, and my B is equal to minus 2, 0, 1, 3, 1, 0. So the column of this one is what? 1, 2, 3. So it has 4 columns. And this one has how many rows? 1, 2. So it has 2 rows. Although they are of the same order, but the column of the first matrix is not the same thing as the column of the second matrix. That means cannot be multiplied. Cannot be multiplied. So is it understood? Now, let's now talk on how to perform the multiplication of matrices. After checking whether we can multiply them, then let's know how to multiply them. And then another thing that you have to know is that after knowing that you can multiply them together, so this is order 2 by 3 and this is order 3 by 2. So you can quickly know the order of the results. After the multiplication, we want to know the order that our answer is going to be. So that means so that when we are multiplying and we are getting another order, so we quickly know whether we are correct or not. So you cancel this the column of this one and the row of this one, they are the same. So our answer, so that is, if we want to multiply order 2 by 3 by order 3 by 2. So what we're going to do is that you cancel this column, you cancel the row of the second row. So our answer will be order 2 by 2. Now, I told you that the first thing that you have to check is the column of the first matrix. What is the number of columns here? 1, 2, 3. So this one has 3 columns. And also the row of the second matrix, 1, 2, 3. So it has 3 rows. So since they are having the same number of columns of the first matrix and the number of the row of the second matrix, they are the same. That means I can go ahead and multiply them. So now the next thing that I'm going to do is that I want to find A multiplied by B. So my A multiplied by B is going to be, I'm going to write A 2 minus 4 1 3 9 0. Then multiply by minus 5 0 8 minus 1 6 and 4. So the next thing that I'm going to do now is that I will now go to the first row of the first matrix. Then I'm going to this first column of the second matrix. So what I'm doing now is that I'll multiply the first element on the first row of the first matrix by the first element on the first column of the second matrix together. That is, I'm multiplying 2 by minus 5. So I have 2 multiplied by minus 5. So the second thing is that I'm multiplying the second element of this first matrix by the third element, that is the second element of the column of the second matrix. I'm multiplying minus 4 by 8. So I'm now adding them to the first operation that I've performed already. So I have minus 4 multiplied by 8 plus the third element on the first row of the first matrix multiplied by the last element on the first column of the second matrix. That is 1 multiplied by 6. So, and I'm adding them to the previous ones. So 1 multiplied by 6. So that is the first element of the answer. So what I'm doing next is that I'll take that the same row. I'm going to multiply it by the second column of the second matrix. So that will be the second element of this one. So what I'm saying in essence is that I'll multiply 2 by 0 first. So I have 2 multiplied by 0 plus the second one, which is minus 4, multiplied by minus 1. So I'm adding them to this one. So I have minus 4 multiplied by minus 1 plus, I'm multiplying 1 by 4. So, and I'm adding them here. So 1 multiplied by 4. So the next thing is that I'll go to the second row of the first matrix, which is 3 9 0. Then I'm multiplying them by the first column of the second matrix. So the first thing is that I'm multiplying 3 by minus 5. So I have 3 multiplied by minus 5. Let me write it up. 3 multiplied by minus 5. So now we are adding In addition, in multiplication, we are adding. So the second one, which is 9, 9 multiplied by 8, plus the last one, 0 multiplied by 6. So we are adding them together. So now I'll go to this side now. So this second row of the first matrix multiplied by the second column of the second matrix. So I have 3 multiplied by 0. 3 multiplied by 0 plus 9 multiplied by minus 1. So 9 multiplied by minus 1 plus 0 multiplied by 4. So plus 0 multiplied by 4. So now let's simplify. So my A multiplied by B will now be equal to, so let's perform this operation there. So 2 multiplied by minus 5 gives me what? It gives minus 10. Minus 10. Then remember to add. Minus 4 multiplied by 8 gives minus 32. So minus 32, embrace it in the brackets. Plus 1 multiplied by 6. Write it. So let's go to the second element. 2 multiplied by 0. Plus minus 4 multiplied by minus 1. That is what? Plus 4. Plus 4. Plus 1 multiplied by 4. So I'm going to the third element here. So check here, we have 3 multiplied by minus 5, and that is minus 15. Minus 15 plus 9 multiplied by 8, that is 72. So plus 72 plus 0 multiplied by 6, that is plus 0. Now go to the fourth element of the answer. So 3 multiplied by 0 is 0. Plus 9 multiplied by minus 1, that is minus 9. So plus minus 9. Then 0 multiplied by 4 is 0. So plus 0. So our answer A multiplied by B is equal to minus 10 plus times minus 32. Minus 32. Then plus 6. So let's do this one. 0 plus 4. 4 plus 4, 8. So let's do this one directly. Minus 15 plus 72 plus 0. That is 57 plus 57. So let's do that one. Plus 57. 0 plus minus 9. That is minus 9. So let's perform this one. The first one. Minus 10 minus 32. That is minus 42. Minus 42 plus 6. That is minus 36. Minus 36. So let's write all those ones. Minus 9. So that is how to perform multiplication of matrices. So they ask us to find their multiplication. So the first thing is that let's check what is the number of columns of the first matrix. This is 1, 2. So this one has 2 columns. So what's the row of this one? 1, 2, 3. It has 3 rows. So can you answer that? Can they be multiplied together? Yes or no? No. They cannot be multiplied together. Why? Because the number of column here is not the same thing as the number of row here. The number of column of the first matrix must be the same thing as the number of rows of the second matrix. So since number of column of first matrix is not the same thing as number of rows of second matrix, so it means that these matrices cannot be multiplied together. So that is the best answer that we are going to say. So example 3, matrix A and matrix B. So we want to check whether they can be multiplied together. So the first thing is check the matrix, column of the first matrix. 1, 2, 3. So this one has 3 columns. So check row of the second matrix. 1, 2, 3. So it has 3 rows. So since the number of column of the first matrix is the same thing as number of rows of the second matrix, that means they can be multiplied. So they can be multiplied together. Why? Because the number of column of the first matrix is the same thing as the number of rows of the second matrix. So after knowing that they can be multiplied together, let's now multiply them. So the first thing is that go to the first row of the first matrix, then the first column of the second matrix. Multiply them together. You multiply, you add. Is equal to. So you take the first element here, multiply by 2. So we have minus 1 multiplied by 2 plus 0 multiplied by minus 1 plus 2 multiplied by 0. That's the first element. So we are still on the first row of the first matrix. So multiply it by the second column. So we have minus 1 multiplied by 1. That is minus 1. Without wasting our time. 0 multiplied by 8 plus 0. 2 multiplied by 1 plus 2. So the first row again multiplied by the third column. So minus 1 multiplied by 0, 0. 0 multiplied by 6 plus 0. 2 multiplied by minus 2. So that is plus multiplied by minus, that is minus 4. Go to the second row of the first matrix, multiplied by the first column of the second matrix. 7 multiplied by 2, 14. Plus 9 multiplied by minus 1, that is minus 9. No, we are having plus A already. So plus multiplied by minus 9, that is minus 9. Minus 6 multiplied by 0, 0. So plus 0. Then second one is here. The second row multiplied by the second column of the first matrix. 7 multiplied by 1, 7. Plus 9 multiplied by 8, 72. So plus 72. Plus minus 6 multiplied by 1, that is minus 6. So minus 6 multiplied by this plus, it gives me minus 6. So we are still on the second row of the first matrix, but we are multiplying it now by the third column of the second matrix. So 7 multiplied by 0, 0. Plus, so we are still on the second row of the first matrix. So we are multiplying it by the third column of the second matrix. So 7 multiplied by 0, 0. Plus 9 multiplied by 6, 54. So plus 54. Plus Minus 6 multiplied by minus 2, that is plus 12. So plus 12. Third row of the first matrix. So we are multiplying it by the first column of the second matrix. So minus 3 multiplied by 2, that is minus 6. Minus 6 plus 2 multiplied by minus 1, minus 2. Minus 2 multiplied by plus, minus 2. 4 multiplied by 0, 0. So plus 0. So we are still on this third row multiplied by the second column. So minus 3 multiplied by 1, minus 3. Plus 2 multiplied by 8, 16. 4 multiplied by 1, 4. So plus 4. Now, on third row, but now multiplying by the third column of the second matrix. Minus 3 multiplied by 0, 0. Plus 2 multiplied by 6, 12. Plus 4 multiplied by minus 2, minus 8. Minus 8 multiplied by plus, minus 8. So now let's simplify. So A multiplied by B is equal to minus 1 multiplied by 2, that is minus 2. 0 multiplied by minus 1, that is 0, plus 0. 2 multiplied by 0, 0. So I have minus 2 here. Minus 2 plus 0, minus 2. Minus 1 plus 0, minus 1. Minus 1 plus 2, that is 1. Plus 1. 0 plus 0, 0. 0 minus 4, minus 4. Now here I have 14 minus 9, that is 5. Plus 0, 5. 7 plus 72, that is 79. 79 minus 6, that is 73. So I have 73 here, plus 73 here. 0 plus 54, 54. 54 plus 12, that is 66. So I have 66 here, plus 66. 14, okay, minus 2, minus 6, minus 2, that is minus 8. Minus 8 plus 0, minus 8. Minus 3 plus 16, that is 13. 13 plus 4, that is 17. 17 is here. 0 plus 12, 12. 12 minus 8, 4. So now you can say my A, B is equal to the row here is my row 1 is minus 2, 1, minus 4. Row 2 is 5, 73, 66. Row 3 is minus 8, 17, 4. So, I told you the other time that you can easily know the order of your answer. So, what is the order of the first matrix here? This is order 1, 2, 3. 3 by 3. So, multiply by order 3 by 3 as well. 1, 2, 3, 1, 2, 3. So I told you are cancelling this one, you cancel this one. So the answer will be order 3 by 3. So that is how to find multiplication of matrices. Here is an exercise for you. So define diagonal and identity matrices. So if matrix A is this, matrix B is this, and matrix C is this. So determine A plus B. Number 2, A multiplied by C. Number 3, A multiplied by B. Number 4, B multiplied by C. Number 5, A multiplied by B multiplied by C. Now, there's another thing that I'm supposed to teach you, that is scalar multiplication. It won't take time. So this is when you multiply a matrix, a particular matrix by a constant. So let's say matrix A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So and you want to multiply it by 3. So here multiply by 3. So it's the same thing as 3 multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will just be, you are going to multiply all through by 3. 3 multiplied by 1, 3 multiplied by 2, 3 multiplied by 3, 3 multiplied by 4, 3 multiplied by 5, 3 multiplied by 6, 3 multiplied by 7, so 3 multiplied by 8, 3 multiplied by 9. So that is our 3 multiplied by 8. And the answer is going to be 3, 6, 9, 12, 15, 18, 21, 24, and 27. So what we are saying in essence is that if you have a constant multiplied by a particular matrix, so you are going to get that constant multiplied by it all through. So this will be k multiplied by 1, k multiplied by 2, k multiplied by 3, k multiplied by 4, k multiplied by 5, k multiplied by 6, k multiplied by 7, k multiplied by 8, k multiplied by 9, where this k is a number. So that is what I remember that I have not taught you. So till I see you in the next class, please make sure you do this exercise. I'm going to write the answer in the comment section, then I'll still do solution on it. So till I see you in the next class, thank you, bye bye.